Hey guys, so let's continue what we were discussing in the previous video. So we were looking at displacement, average velocity, average speed, instantaneous velocity, instantaneous speed. So we looked at Thomas moving, so we looked at 3 examples. So what I wanted to do now is to plot the position versus time and the velocity versus time graphs in the 3 scenarios. So let's look at example 1 where Thomas moved from x equals 0. So Thomas moved from x equals 0 to x equals 10 centimeters in 2 seconds. So how would the position versus time graph look like? What do you guys think? So pause the video and think about it. So if you don't have your own idea, then it's going to be more challenging to learn. So let's plot the position versus time. So here's the position and time graph. Okay, so it's a simple scenario. So at x equals 0, at t equals 0, Thomas is at x equals 0, and then remember every second he was moving 5 centimeters. So in t equals 0 over here, and then at t equals 1 second 5 centimeters, and then t equals 2 second 10 centimeters. So gonna just draw the graph at a convenient scale. So Thomas is at, let's say, 5 centimeter at t equals 1 second, and then t equals 2 second 10 centimeters. So then that's your first point, and then second point. So here's your graph. So is this a straight line with a fixed value with a fixed slope? Okay. So that's the position versus time graph of Thomas in the first example we did. Okay. And if you plot the velocity versus time graph, you will get. So since this is a line with fixed slope, fixed orientation of the ruler again means that it's a fixed slope, which means a fixed value of velocity. One value of slope means one value of velocity, as we discussed in another video. So the velocity versus time graph will look like, so the velocity, average velocity was 5 centimeters per second. So there you go. So it's like 5 centimeters per second. So it's just a horizontal line. Okay, and the acceleration will be 0 because this line has no slope. Acceleration is the slope of this graph. So this graph has a 0 slope, so 0 acceleration. So that was the first scenario. Let's look at the second one. So let's look at. So in this case, in the second example, Thomas was moving at a different pace. So let's draw it over here. Okay. So Thomas is moving towards the negative now. So Thomas starts over here at x equals 15, and then moves back, and in 2 seconds Thomas is at x equals 5. Okay. So again, think about the position versus time graph before looking at the answer. Pause the video and think about it. So this is scenario 2. So at t equals 0, Thomas is at x equals 15. So this is your time axis, this is your position axis. So at t equals 0, Thomas is at, so let's say this is 5 centimeters, this is 10 centimeters, this is 15 centimeters. So this is where Thomas is at t equals 0, and then at t equals 1 second, Thomas is, let's say this is 1 second, this is 2 seconds, this is 3 seconds. So Thomas is over here, okay, and then at t equals 2 seconds, Thomas is at 5 seconds. So this is your second point, and this is your first point. So this is the line. This is the line. So this is a line with negative slope. Remember, we got a value of negative 5 centimeters. So the slope of this line is the velocity, and it's negative 5 centimeters. So if you plot the velocity versus time graph, it should be a line with, so it's going to be a line on the negative vertical So it's going to be aligned with negative value of velocity. So till 2 seconds, it's just going to be, so like 2 seconds, till 2 seconds, we'll just have this. So the value is -5 centimeters per second. Okay, so one thing is that in this case, when you have a line with fixed slope, the instantaneous velocity is equal to the average velocity. This is something that students always ask. In this case, when you have a fixed value of velocity, what do you do when you take a derivative? You zoom in, essentially zoom into the function, right? At a very small interval. So when you zoom into a very small interval, the slope doesn't change. The line has a fixed slope. Okay. So instantaneous, in this case, average velocity for this line segment is just equal to the instantaneous velocity. Okay. And it was even for example 1. We did the graph, instantaneous velocity is equal to the average velocity for this segment. So V instantaneous is equal to V average. Okay? And if you plot the instantaneous speed, so as I said, instantaneous speed is the magnitude of instantaneous velocity. So since the instantaneous velocity is the same as average velocity, so if you plot the instantaneous speed, so let's say speed instantaneous, it's just going to be the same value, but with the, you just get rid of the negative side. So it's just like some 5 centimeters per second, okay, horizontal line. So that's the instantaneous speed. Okay, is this the magnitude of instantaneous velocity? Since this is 1D, you just get rid of the negative sign. And when you go to 2D and 3D, you have to use the Pythagoras theorem to get the instantaneous speed. But in 1D, it's easy. Okay. Now let's look at the last example. So in the last example, we had where's the last example? Here. So in the last example, we had Thomas moving in a different way. So he starts at x equals 0, and then goes to 10. Starts at x equals 0, goes to 10, and then comes back to 5. Okay. So what do you think now is the graph? Think about it. Try to make a graph yourself, and then look at the video for the answer. So position versus time now for Thomas in the third scenario. At t equals 0, we are, Thomas is at x equals 15 at x equals 0. Okay, so say this is 5 centimeters, this is 10 centimeters. So at t equals 0, Thomas is over here. 1 second and 2 seconds. So t equals 1 second, Thomas is over here, and then t equals 2 seconds, Thomas is over here. Okay, so Thomas is moving with velocity, with the velocity that is for this interval. The velocity of Thomas for this interval is the slope of this line. Okay, and at 2 seconds, Thomas changes direction, and then I'm just going to assume that it's an instantaneous change. So then at t equals 3 seconds, he's back at x equals 5 centimeters. So it's going to be like this. Okay. So then if you want to plot the velocity versus time graph, it's going to be a line with positive slope. So so this positive slope is 10 rise over n, so 10 divided by 2, that's 5 centimeters. So that's going to be 5 centimeters per second. Okay, so that's going to be a horizontal line till 2 seconds. So till 2 seconds, it's just going to be like this. And after 2 seconds, it's again rise over n, so it's -5 over 1, so it's -5 centimeters. So the graph jumps below to -5 centimeters. So somewhere here, -5 centimeters per second. Okay. So after 2 seconds, space over here, so just like a horizontal line, that's value -5 centimeters till 3 seconds. So I mean this to be 3 seconds. Okay. So that's going to be the graph of Thomas. So if you want the instantaneous speed, it's just you just get rid of the negative sign. This line moves up. So the instantaneous speed is just going to be like a horizontal line that continues on. So that was it for the graph for the position and velocity versus time graph of Thomas for the 3 situations we discussed. If you have any questions, post them in the comments, and hope you like the video. Please subscribe. Thank you.